This is Unit 5, Lesson 6, Part 3, the final part called Mass-to-Mass Stoichiometry, and students will be able to create a hypothesis for how many grams of one substance is needed in a chemical reaction, given that you know the mass of a different substance in that reaction. The vocabulary terms are review, but they're still important: mole ratio and molar mass. So before getting into all the math involved, I just want you to understand our plan of attack, how we problem solve this type of problem, or maybe even what our problem is in the first place. So the problem is that we have a known mass of a substance in the reaction, I'll call it substance A, and we want to figure out the mass of another substance. So if I'm going to stick with my analogy of baking that I use a lot, it's comparable to, okay, I have 10 grams of sugar. How many grams of cookies does that mean that I can make? Okay? That's what we're doing here. It does involve a lot of math. Okay? All right, so let's, again, try to put this in perspective. Let's say we're working with this chemical reaction. Again, easiest one, hydrogen and oxygen form water. Ignore the ABC for right now. What we learned the last couple of lessons, is that what really determines how much of a substance we can make in a chemical reaction is the mole ratio, okay? Where we convert moles of A to moles of B. That's exactly what we did in our last step. So we would call this the mole ratio, right? The balanced equation says, if I put in 2 moles of this, I'll get out 2 moles of this. Put in 1 mole of this, I'll get out 2 moles of this. Okay, so that's the law of conservation of mass says that has to happen. But if I asked you to test a hypothesis, meaning, okay, you tell me if I put in 2 moles of this, I'm going to get out 2 moles of that, and I say, go test it. Go grab 2 moles of H2 and see if you react it with oxygen, see if you make 2 moles of H2O. Go do it. Go see if you can do it. You would run into this problem that you can't measure 2 moles of H2. Imagine a bunch of particles. You can't grab particles. So this you cannot actually do at the lab bench. So obviously we run into a problem. But I would not lead you astray. So we have to actually get some value before that and convert it into moles. So we cannot measure moles, but what we can do is we can take grams of A and we can convert, which just means change, into moles of A. Okay, and again, A is just a substance. It's a whatever substance it is that you want to deal with. In this case, I just sort of labeled it so it would make sense. It's H2. Okay, so in that step, if I have grams, I can convert them into moles, and then I will have moles. And I can measure grams, so that's useful. In order to do this step, you need the molar mass. Okay? So for this first step, I'll deem it step 1, you need molar mass. I'm going to show you how to do all this, but I hope you're writing this down because this is our plan of attack. In step 2, that's the one I already wrote. It's actually the most important step. We just can't measure it, so we need these steps before and after. We're going to use our mole ratio and can convert from moles of one substance into moles of another substance. But I'm going to end up with moles of B, and I can't measure moles of B. So my last step is to convert moles of B into not moles, into grams of B. Because I can actually measure grams. All right? And then, look at that. that will get us our mass of substance B. Because in this step we are converting, again, moles to grams, you also use molar mass for what I will deem step 3. So this is a 3-step process, which I like to refer to as a mole ratio sandwich with some molar mass bread. It's 3 steps: molar mass, mole ratio, molar mass. All right, write this down, and now we're going to try a problem. Okay, so we're going to do an example problem here. The problem says if 5 grams of oxygen gas goes into the chemical reaction, how many grams of water will be produced? Again, I recognize this as a stoichiometry problem because it's talking about a chemical reaction, 1. Second, it gives me the mass of one of the substances in the reaction. And then 3, it asks me how many grams of another substance I'll have. That is certainly a stoichiometry problem. So again, my plan of attack, I'm starting with grams of oxygen gas. I'm going to convert those into moles of oxygen gas. I'm going to have to convert those into moles of, what am I interested in? Water. And then finally, in the last step, I can convert that into grams of water. So the arrows out of each represent a step. In your graphic organizer, which you should have in front of you, I'll label the steps the same as I would before. Okay, 1, 2, and 3. Okay, so let's start with our 5 grams of O2. I want to convert that into, oops, I probably didn't give myself enough room there. Sorry. I want to convert that into moles of O2. So see how I'm thinking about what I'm starting with in my first step and what I'm ending with? That's important. And my next thought is, if grams of O2 is here, and I want to convert it, I want to get rid of it, I want to cancel it out, where does it have to go next? It has to go on the bottom. And what I want to get to has to go on the top. Again, notice my first thought was not numbers. I know you've been trained to think about numbers. And I'll do the numbers in red. So if you look at your graphic organizer, how do we compare moles to grams? It should say on there molar mass. So here's where you grab your periodic table, you find oxygen, and you find its molar mass. If you look, it says 16, and that's the mass of 1 mole of oxygen, but we have 2. So we are going to say the molar mass of 1 mole of O2 is 32 grams. Okay, and then you have to go in your calculator and find an answer. Again, PEMDAS says do parentheses first. Okay, so 1 divided by 32, got 0.03, and then multiply it by 5, I got 0.156. Okay, and I'm going to bring that down here. And I'm going to ask myself, what do I want to get to next? Step 2 says go from moles of O2 to moles of H2O. That must be what I want to get to next, so I put it over here to remind myself. Moles of H2O. Alright, so I need to change, this second step is a mole ratio step. We did a whole lesson on this. Okay, that's why. My first instinct is to put moles of O2 down here, because I want it to cancel out. Oh, I forgot to cancel it out up here too, okay? So you cancel out the moles of O2, and therefore, moles of H2O goes on the top. Now this is different from the last one. The last one was moles and grams. This is moles and moles. This is our mole ratio. And I remember that I look up to the balanced equation to find the ratio that the balanced equation says I need. It says that for every 1 mole of O2, I should be making 2 moles of H2O, right? A 2-to-1 ratio. So again, I am just going in my calculator. 2 divided by 1 is 2, and then I'm multiplying it by what I started with, you should get 0.313. And I'm rounding a little bit there. Okay? I know I'm doing crazy colors here with the red and the blue, but... So I write my answer down here, and I hope you notice for everything I'm writing, I am writing a quantity, a unit, and a substance. It's important. Okay? And our last step, my plan of attack, up here in blue says moles of H2O. I can't measure moles, so my last step is to convert it into grams. Okay? So like a machine by now, you should automatically be putting moles of H2O down here. Don't carry that number down. I don't want the number. I want the moles of H2O so that it cancels out. And what do I put on top? Oops, I forgot to think about what I'm trying to get to. Grams. Grams of H2O. And so my answer is in grams of H2O. Grams and moles. Whenever I hear grams and moles, I always think molar mass. So go ahead and look at that periodic table for step 3. Find the molar mass of water. Pause me so you can find it. And when you're ready, play me again. Okay, you should have gotten 18.02 for every 1 mole. I always get asked, is that 1 mole or is that the 2 up here? And you have to remember that molar mass, by definition, is the mass per 1 mole. Okay, it's like 4 quarters for $1. It's got to be per 1. Okay, people tend to confuse the second step with the other ones, so you just got to go over it a lot in your brain to have it make sense. Again, all right, PEMDAS says I have to divide 18.02 by 1, which gives me 18.02, and then I'm going to multiply it by that 0.313, and I end up getting, final answer here, 5.63 grams of H2O. I always do a double check to make sure that my answer is what they were asking for. So what were they asking for? Grams of water, and I gave them grams of water. So I realize that this is a very long problem with a whole bunch of stuff. You should probably pause, rewind, try this problem all over again, all by yourself, and see if you can get the answer, because I am sure that that did not stick in your brain. So you have to do work to see if you can get it yourself. Listening to me do all of this work does not mean that you are able to do it yourself. Okay? So go ahead and try this problem again and see if you get the same answer.